Okay, so let's take a shot at this. First thing, notice that over here and here, this can be broken down into this. 1 over secant x times tan x, right? Tan x over 1. That's essentially what that is. Because if you multiply this fraction out, right? I'm just put 1 over here to show you. Tan x times 1 is tan x. Secant x times 1 is secant x. You get tan x over secant x. So you can divide it like this. Well, tan x is just sine x over cos x. That's what tan x is. It's one of the identities. And then secant x is the same as 1 over secant x is the same as cos x. That's what cos x is equal to. 1 over secant x. That's one of the identities. So that means that can be replaced with this. This is 1 over secant x is the same as cos x. Well, when we multiply cos x times sine x and divide it by cos x, that cancels. So the left is just that. So I'm going to assume we can do the right. If you look, oh, this is disgusting down at the bottom here. But let's focus on this part here. Well, let's focus on this. I already did this a little bit for you. This is hard to see. It would be a lot easier if it said sine squared minus cos squared. But it's the reason they did to the 4 is going to be obvious in a second. The square root of sine to the 4 is sine squared. The square root of cos to the 4 is cos squared. And there's a minus in it. So that means that's a difference of squares. Go back and revisit your difference of squares, but the difference of squares for this, in this case, are sine squared x. I'm going to make it a little bit smaller to fit it all in. Plus cos squared x, all times the other square root of it. Fix it. This might not fit. Sine squared x minus cos squared x. I'm just going to put the cos squared there instead of cos squared x. Well, this right here, this part right here, this is this bracket times this bracket will give you this. Well, this part right here is equivalent to 1 in your identities. So we can pretty much get rid of it. Which means on the top we're left with sine squared x minus cos squared x. I'll put the x. And the bottom is just a bunch of math magician stuff. So remember that this is all over this here. All over this here. So we're going to focus on the bottom. I'm willing to bet that this is going to turn into something that's essentially going to be sine squared x. But we'll see. Okay? So we get sine x times tan x. But remember that tan x is sine x over cos x. Okay? And then we see 1 over secant x. And we've already seen that 1 over secant x is the same as cos x. And then it's subtracting something. It's subtracting this. But we definitely can see, well, these cos x cancels, and the sine x times sine x is sine x squared minus cos x squared. So I actually think this identity is incorrect. I think your teacher made a big mistake here. And this can be used to your advantage to argue that she's made a big mistake here. Because this bottom, therefore, comes out the same as the top. Comes out the same as the top. And that means they cancel out completely. Sine x, if she's saying we have to solve it, then what she's saying is sine x is equal to 1. If she's asking for the solution, this is not an identity at all. We've actually proven that this is not true because sine x does not equal 1. But if she's asking you to solve this here, and we go back to our unit circle, and we look at where sine x is equal to 1, it's 0, 1 here. Or sorry, that's 1, 0 here. So that means sine of 0 is 0. And then up here it's 0, 1, which means sine of 90 degrees is equal to 1. Then over here it's minus 1, 0. So that's 0 is sine of 270. And then down here, it's 0, comma, minus 1, which means, or sorry, sine of 180 is 0. That means sine of 270 is minus 1. So the only place that sine is 1 is at 90. So that means in this case, if she's asking us for the solution, x is 90 degrees. This is not an identity question. This could be a solve for the angle question. But if she's saying it's an identity question, in other words, that left side must equal right side, it is not true.